Hi, my name's Ben Lackey. I'm a partner architect with DataStax. We've been working quite a bit with Microsoft on building out some Azure Resource Manager templates for deploying DataStax to Azure clusters automatically. In a previous video, I showed you how you can use Azure Marketplace to deploy those. In this video, we're going to go through a more technically sophisticated way to do that, using the command line interface with Azure, as well as deploying directly from GitHub. As always, if you have any questions, by all means email me, ben.lackey@datastax.com or @benofben on Twitter. Okay, so let's get started. First off, I'm going to kill PowerPoint, so make that go away, and open up a web browser. So, up on GitHub, we have some Azure Resource Manager templates. This template we've built. This is all publicly available, so you can go here, you can clone the repo, and you can do whatever you want with it. If we scroll down a little, we see this Deploy to Azure button here. And this is defined in the README. And we're going to use this to deploy a cluster. I want to point out a couple things about how that works before we do it. One is if we click on the README here and we go look at the raw text of the README, you'll see here the underlying HTML for this button. And in it, you can see hard-coded the location of this main template.json within this repo. So if you do fork the repo and you want to use that button, be sure to redirect it. Otherwise, it'll continue pointing at this one, and things you may not expect might happen. The other little bit similar to that, if I go back here and we pull up this main template.json, there's a template base URL in here, which is also this repo. So once again, if you fork it, be sure to update that to wherever you forked it to. So let's go back and let's give deployment a try. Scroll down, deploy to Azure, and click that. This redirects us over to Azure, where it's going to try to deploy those templates, and it wants us to enter an account info. I've already signed up for an account. That's associated with an Azure subscription. You can do the same thing by going to the Azure website. Click on that, and it thinks for a minute, and okay, it wants my password. Let me give it that guy real quick. And redirects a couple times. We go to the portal, and we go to the template deployment, all automatically. All right. In our last video, we deployed a 90-node cluster. Let's give it a 36 a try this time, I think. So let's do the same machine type, the D12s. As mentioned, there are some other machine types available. One thing I would warn you about, in this interface, unlike the Marketplace interface, there are no validations. So we can select invalid parameters, like I know East Asia, where I'm planning to build this cluster, doesn't have G5s, but the template will still let us select them. So you have to be a little more careful in here. The username, I'm going to pick DataStax. That's a similar thing. It's not validated. So usernames like admin, administrator, and user are all on Microsoft's blacklist. If you try to create a deployment with them, that deployment will fail. So don't do that. Password, I have a default in here of foo123!! Reason I do that is there needs to be an uppercase letter, a lowercase letter, a number, and a symbol. 3 out of 4 of those things to constitute a valid password. This password will be used for making SSH connections. It will also be used by our Ops Center administrative product to do some deployment on the nodes that we'll go through in a little more detail in a bit. DataStax username is a username I got from datastax.com/download, and that is used by Ops Center to go to an apt-get repo and download the actual software. So my username happens to be ben.lackey_datastax.com. Yours is probably email address with @ replaced with an underscore. Paste my password in there, and it looks like we're good. I'm going to hit OK. My subscription, the default, is already selected. I'm going to create a new resource group for this. I'm going to call it, how about Ben Group 103. That all looks good. Resource group location is East Asia. And yeah, actually, I'm just going to drop the group from here. I'll call it Ben 103. That looks good. Legal terms. This is Microsoft's own terms. I'm going to accept those. And at this point, I think I'm ready to go. Let me remove that old tile. So this is our guy up and deploying. Deployment started. We can look at the audit logs here, though probably not going to be much in here yet. Yeah. Last you can see I deleted a resource group 10 minutes ago, but nothing new from this resource group. Okay, so while that does its thing, why don't we go back to GitHub and have a quick look at this. You'll see here this URL. I'm going to copy that, and we're going to clone this repo locally so that we can do a deployment locally. So there's a terminal. Let's clear this, ls, okay. So you know I'm not cheating. All I have is a parameters file. That happens to have my DataStax password in it, so we're not going to look at that. But I'm going to do a git clone of our repo and hit enter. And it's thinking, it's cloning it. It's not a very big template, so looks like we have a new directory now. Let's go into that and take a quick look. In here, you have a couple things. Probably the main things are actually the ones with main in their name. There's a parameters file, which are parameters we're going to pass in, and those are passed into the main template. So we can look at the parameter. Oops, that wasn't the file I wanted. Let's look at the parameters file, and you can see it has a node count of 90, though I think I've overridden this. I think the file we're going to use has a smaller cluster size. D12s, username, password, my DataStax username and password notably blank. The idea is you can download this parameters file and input your own information into that. So that is passed into this main template.json. Let's actually give that a go and have that run. So the command to do that is Azure Group Deployment Create -f, pass in the name of the main template, -e, the name of the parameters. Then we need to give it the name of the resource group we want to put it in. So I'm going to do Ben 104 since we have 103 going from the deploy button. And finally, just an identifier for that. In this case, we're going to have to create a resource group, this Ben 104. It does not exist yet. So let's do that real quick. And that's Azure Group Create, the name of the resource group, and then where you want to put it. And we're going to put it in East Asia. In this template, a little different from the marketplace, we're using the region that the resource group is in to determine where everything else is going to go. Just one fewer parameters for you to specify, trying to make life a little easier. All right, so it looks like we have a new resource group created, at which point we can run this command. Ooh, and that did not work. Know why it didn't work? We're not in the right directory. Change to the right directory, and let's try that again. Okay, because it expected / main template.json, and we were in .. slash, so yeah. All right, so it created the deployment. It's waiting for the deployment to complete, and that'll take 15, 20 minutes, something like that. All right, let's go back and let's check on how our other guy is doing. So notifications, deployment is still running there. Okay. Let's see, what else can we look at? One other thing I'd like to show you is if we go over here to my Windows virtual machine, we can see another way to do these deployments. And this is with the Azure PowerShell. This, I would note, is different from the normal Microsoft PowerShell. This is Azure specific, but you can install that, and then it has all sorts of commands, like add Azure account is kind of the first thing you typically do. So you'd log into Azure here, and then you'd be able to create groups and do things like we just did in the CLI over there. Right. Let's go back to the web browser, and real quick, I want to point you at where you can install the PowerShell or the CLI we've just been using. So if I search for, you can tell I've done this before, Azure CLI install, I'll get directed over to this article. And this is a great write-up, talks about how to install the CLI. I won't take you through it and belabor the point because this will really sort you out and you can figure it out. The CLI is cross-platform. It'll run on Mac, it'll run on Windows, it'll run on Linux. It uses Node.js, it uses NPM, a couple other technologies underneath. The PowerShell is sort of like the native version of that. It runs on Windows and Windows. There we go. Requires the .NET framework. So that's another alternative for interacting with all this stuff. Okay, so let's have a peek at that. Yeah, it's still going. And let's go back to GitHub and let's start looking through the template and kind of see what we have while we wait for our two deployments to complete. We already talked about the README. We've taken a look at the main template parameters that you pass in and can modify, and those are passed into the main template. The template starts off kind of accepting those parameters with different values that are defaults that are allowed. We talked about the template base URL here. Then we define different sizes of clusters, 4, 12, 36, and 90. We'd like to change this a little so you can define any size cluster, but there are a couple limitations that are preventing that at the moment that we're working on. Below that, we define a rather large subnet, a /16 in the private 10 space. And then we define smaller subnets in each of those, 10.0.0, 10.0.1, and so forth. Each of these subnets are going to get 18 DataStax nodes. And depending on how many nodes our total cluster has, we may have a total of 5 subnets. Finally, Ops Center is going to get a private IP address of 10.0.0.5. It'll also get a public IP address. The operating system for all this is Ubuntu. This is a standard image that lives up on Azure that Canonical maintains, and DataStax just uses it to build on top of. It's kind of nice because that image is always kept updated by those guys, and you, using our templates, are always ensured an up-to-date build. We have a couple scripts that these templates are going to call. Node.shell runs on the node. Basically, it installs Java, and then it calls this script, and this script partitions a disk, an ephemeral disk. In the case of the D12, that is a 200 gigabyte SSD. We'll look at that a little later too. Opcenter.shell runs on the Opcenter machine, so if you deploy a 36 node cluster, you'll actually get 37 nodes. The one extra node is running Opcenter, and it kind of administers the whole cluster. All right, scrolling down a little more, we see calls into other templates. These are sort of the child templates of the main deployment. So let's go back here, and you can see those child templates, but I think the most interesting thing to look at in all this is the opcenter.shell. And that's invoked with a number of parameters, kind of passing in things you might recognize from the highest level. It also gets these IP ranges that are the IP addresses that DataStax is going to be installed on, the private IP addresses, expressed in a kind of concise format that is convenient to pass as a bash parameter. So we parse all those, and then we install Java. This is kind of interesting. So we're installing Azure Zulu. Zulu is kind of a stripped down version of OpenJDK, and we ended up using it for this for a number of reasons. The install's a little smaller and has fewer packages than some alternatives. And another reason is you're spinning up very large clusters. We've actually found that if we're spinning up several hundred nodes simultaneously, we'll overwhelm the repos that are serving up Java. And we've done that with the Oracle repo, we've done it with the Canonical repo, and we did it with the Azure repo. But the Azure guys were really nice and upsized their repo so it could deal with the load. So we're using that and we're quite happy. Once that's all installed, we install Opcenter. And then we fiddle with the Opcenter config file, opcenterd.conf, to turn on authentication. It's off by default, and to turn on SSL. Finally, we start Opcenter up, and then we go get some things ready for it. In here, we sort of uncompact those IP ranges we'd created, and then we go through them and we grab the SSH key of every node we're going to connect to. Once we have all those, that's our fingerprints, we build out this JSON file. And this JSON file is the Cassandra configuration. It's a rather long JSON document, as you can see. Most of these are default values. There are a small number of exceptions I'll point out. One is auto bootstrap, which by default is true. We've set it to false because we're spinning up a whole bunch of nodes simultaneously, and if they all try to bootstrap against each other, they'll just time out. So it needs to be false. A little further down here, you can see this is mount save caches. That's on our ephemeral storage. And you'll also see a little further down, the commit log is going over there as well, as is the data directory, wherever that is hiding. Then finally, in our data center, we're going to pass in all the IP addresses and the accepted fingerprints. In this case, we're installing 4.7.1 of DSE, DataStax Enterprise. This is currently the newest version that Opcenter supports, though they're always adding support for new versions. We write this file out to a directory. We can look at it for debugging if we need. give Op Center a little bit of time to start up, and then we grab a session token and finally pass this JSON document we've created to Op Center. At that point, it begins the provisioning and just kind of does its thing. One interesting side effect of this is this script does not block, so your Azure deployment will show completed while Op Center is still working. And there are pluses and minuses to this. We're currently trying to decide if synchronous or asynchronous behavior is preferable. If you have a strong opinion about that, by all means, let me know. Okay, so we can flip back here. One other thing that's interesting is the node.shell script. That node.shell script, as I mentioned, installs Zulu, basically the same as before, and then it calls that VM disk script. All right, so that's a pretty good review of the template and what all that does. Let's go back here, have a peek. Okay, this deployment is still running. And then on our command line, that's still running. So at this point, I'm going to pause the recording for a little bit, give this some time to finish, and then we'll return. See you soon. All right, so we're back. I just got a message that the deployment of Ben 103, which we deployed using the deploy button over on GitHub, had just finished. You can see that message here. Oh, and look at that, there's Ben 104 too, the one we deployed on the command line. So 2 minutes ago it finished at 6:40, and that one finished at 6:38. Okay, great. And we can look at those, and logs on success aren't terribly interesting. You know, hey, I was successful. But that's kind of a good thing. So those are both running. The next thing to do is probably to go check out Op Center and see that it's running up on those. In order to do that, we need to know where those are running. And one way to find that out is to go to this resources.azure.com, and here you can sort of burrow down under your subscription, under resource groups, and there you can see R2 resource groups. If you expand that under network, under public IP addresses, you'll see a DNS name. And that DNS name is the name of your resource group, in this case Ben 103, cluster appended .region, in this case eastasia.cloudapp.azure.com. All right, so let's paste that in there. And then Op Center is going to be running on port 8888. This is an HTTP port. As soon as I hit enter, this is going to redirect us to 8443, where HTTPS is running, but whatever. So it redirected us. It complains because there's a self-signed certificate here. That self-signed certificate generates an error because, of course, Google doesn't know about that. We can ignore the error, hit proceed here, and go ahead. And there we go. This is the Op Center login. The default username and password is admin, which I think is what's set here. Debating changing this to be the same as the SSH password. So if admin doesn't work, give that one a try. Anyway, let's log in. And that thinks for a moment. All right. Build in progress. Okay, so in this case, I think this was a 36 node cluster, if I remember right. It's installed the software, the configures are done, and some of the nodes have started, but not all of them have started. Let's give that a bit to run, and let's take a look at 104 and see how that one's doing. So if we go back here, close this guy, open this guy up, burrow down to network, burrow down to public IP addresses again, and you'll see a very similar name to that one we just tried. Let's open up another tab, paste that in, the 4/8, hit enter, and same error, different certificate, but also an invalid certificate. Or, well, not signed by a known authority, I shouldn't say invalid. You can replace these with your own certificate rather than the self-signed one we generate automatically. Okay, same login, just the default. And give this guy a moment to think. And there we go. Oh, okay. So this one's a little further along. Smaller cluster, I guess, took a little less time to build. So we have 4 D12s. Each one has a 200 gig ephemeral SSD. So 4 times 200 minus some overhead gives us 750 of usable space, it looks like. All right, that seems great. We can also take a look at the cluster over here. There's 10.0.0.6, .9, .8, .7. So I guess 6, 7, 8, 9. Okay, great. So there's one working cluster. And while we were talking, it looks like our other guy built. There's a nice 36 node cluster here. And this guy probably has a little more storage. Let me hit refresh, let that reload. All right. Okay. Oh, I clicked too soon. There we go. So while 104, which is 4 nodes, had 750 gig, this guy's quite a bit bigger. He's 6 point some terabytes with 36. That's kind of cool. All right. So we've successfully deployed. That's all good. At this point, I'd like to show you a couple things, just kind of showing you around the cluster, helping you understand how to debug and things like that. So this is the name where we can SSH to. Let's flip back to our terminal right here, and you can see where we created the group earlier. One command that's quite useful is Azure group list, and this will list all your resource groups. And it's good to keep track of your clusters and make sure you don't accidentally run a whole bunch and forget about them. So you can see our 2 clusters right there, and then a lot of other people are doing stuff on this subscription. Yeah, so beyond that, another interesting thing you can do is Azure group log show, and then the name of a resource group, so Ben 104. And this will print out all the log information. In this case, our deployment was successful, so it's not very interesting. But in the case something went wrong, this is a really good way to figure out what went wrong. And I sort of prefer to redirect these to a file that I can peruse at my leisure. So redirect ~out104. I think actually if we go over here, yeah, you see a whole bunch of outs. So I bet if we do something like grep out star error, oh, I got that backwards. Grep error out star, yeah, let's see various issues. So scripts that failed and other things while testing various things. So great debugging tool. Highly recommend your, let's pull it up again, Azure Group Log Show as a way to get around. Okay, let's go take a look at one of these boxes. So SSH DataStax, the user we specified earlier, and this is Ben103. This is our 36 node we deployed using the GitHub button. Hit enter. Doesn't know the fingerprint because this is a brand new box. Sure, we're going to go anyway. And then the password I specified earlier, the foo123 exclamation. Hit enter, and I'm on an Ubuntu box. Yeah, so there are all sorts of things we can look at on here. If I go to var log, and under var log there's an op center directory. I need to be roots, sudo su. Let's try that again. And taking a peek in here, there's some helpful logs. So like this one's often good to figure out what's been going on. In our case, everything's okay, so not really concerned. One other thing I found very helpful is under var log Azure, we've written out the output from that provision.json. So if you want to see what we passed into Op Center, this is a good way to see it. And you can see that JSON with all those node IPs is now fully populated, and various other information. So yeah, we've looked at that. Let's go over here to var lib wa agent, and under here there's this somewhat verbosely named directory that starts with Microsoft. Under here, download, and under here is 0. Okay, let's clear all this stuff out. And this is interesting. So you can see opcenter.shell here is in bold. That means it's executable because this is the machine where we executed opcenter. So Azure changed the permissions on that and ran it. And we can actually cat standard out here, and this is the output from the running of that script. So at the bottom was the REST call to opcenter when it wrote the provision.json, and you can sort of work your way back up and see it installing Java and parsing parameters and all sorts of stuff like that. So another very helpful debugging tool. That's probably enough for the op center node. Let's go take a look at one of our other nodes, one of the data nodes. So this is the first one. 10.0.0.5 is the op center private IP. .6 is a DataStax node. Okay, need a password for that guy. Oh, and you know what? That's not going to work since I'm root, isn't it? So let me unrootify myself and do that SSH again. Okay, accept the key and enter my password in. Okay, that worked a little better. Same sort of thing under here. We've got a var log that's got, in this case, a Cassandra directory here. So you can go look at everything you would expect. And it's also got the same var lib wa agent. Right, let's make ourselves root again. wa agent. Under here, Microsoft custom script for Linux. And then I think that was download 0. And sure enough, there's a standard out. You'll notice in this case node.shell is bolded. And we can VI the standard out. You can see it install Zulu, the JDK we're using. And do some more installing. And then at the bottom it did some partitioning. Let's go take a look at the partitioning real quick. So each of these machines comes with an OS disk that has Ubuntu installed on it. That's remotely mounted storage. It's not terribly high performance, it's spinning disk, all that sort of thing. Then these D machines and the G machines we also recommend have SSDs. Those SSDs are ephemeral storage, and Azure chooses to mount those at Mount. Under here, we've created 3 directories. Commit log for our commit logs, data, where our data is stored, and finally the saved caches. One thing I'll point out here, Microsoft puts this data loss warning README that is some pretty severe language about how if you put things on here and the machine reboots, it will go away. So DataStax replicates across different nodes. We can lose one node and that's all right. If you lose a large number of nodes, it is conceivable you could lose data. We're continuing to work with Microsoft on the best ways to handle replication, rack awareness, fault domains, all sorts of things like that. So, stay tuned. Well, we've looked around that node. We've gone over some commands. We've even poked around PowerShell a bit. We've done our GitHub deployments. We've looked at Ops Center. We've looked at resources.azure.com. We've pointed you in the direction of where to install the PowerShell or the CLI. And we've looked at the portal. There's GitHub, where these templates are, and you can sign up and use them and modify them to do what you need to do. Really hope all this video has been useful, and by all means reach out to me if you have questions, if there are areas where DataStax or Azure can help you out. Thanks for your time.